Hi everyone, this is Kiranmay from HNDS department. Today we are going to have a small session on generation and recombination mechanisms in semiconductors. Under this session, we are going to discuss about how the carriers are generated in a semiconductor and how they will get recombined. Under recombination, we are going to see two different recombination mechanisms, that is radiative mechanism and non-radiative recombination mechanism. Uh, Coming to the first carrier generation, in the name itself we are saying that we are going to generate carriers. How we can generate carriers? When a light of suitable frequency or energy incident on a material, what happens? Electrons in the materials absorb that energy and they try to excite from lower energy to higher energy. In case of semiconductors, they try to excite from valency band to conduction band, where they will become free electrons. Due to the excitation of electron from valency band to conduction band, a vacant space will be created in the valency band. That vacant space is called as hole. So one electron excited to conduction band creates one hole in the valency band. This process is called as carrier generation. Now coming to the recombination of carriers, every excited state will have certain lifetime, and the electrons which excited to the conduction state, they are said to be in metastable states. Eventually they will come back to the lower energy state once their lifetime is completed. Due to de-excitation of those electrons, they will come and occupy that vacant space, that is hole in the valency band. Such an occupation of electron into a hole is called as recombination. This recombination is of two types: radiative recombination and non-radiative recombination. Under non-radiative recombination is two types: Auger recombination and trap assisted recombination. First of all, radiative recombination. This recombination mechanism dominates more in the direct bandgap semiconductors than in indirect bandgap semiconductors. Then what are direct bandgap semiconductors? Direct bandgap semiconductors are the things which are having uh, in which maximum energy level of valency band aligns with the minimum energy of conduction band. Whereas in indirect bandgap semiconductors, maximum of valency band does not align with the minimum of conduction band. So in this process, when the electron moves from conduction band to empty valency band associated with an energy released in the form of radiations, then such recombination is called as radiative recombination. Depending upon the material chosen, the output radiation will be either in the form of light energy or in the form of heat energy. The best example for this radiative recombination happens in P-type PN junction diode and also in the LED, where LED will have an output of light energy, whereas PN junction diode will have an output of heat energy. You can see on the screen the recombination mechanism where radiations are emitted due to de-excitation of an electron from conduction band to valency band. A photon will be released whose energy is nearly equal to the energy gap between these two bands, that is conduction band to valency band. And there is one figure which represents the different types of semiconductors, where the maximum of valency band and the minimum of conduction band is aligned in the same direction as of for the direct band gap semiconductors, whereas for the indirect band gap semiconductors, they are not aligned at the same position. So in the transition from the conduction band to valency band is more easier in direct band gap semiconductors, whereas the transition from the conduction band to valency band is little bit critical in indirect band gap semiconductors. Then coming to the non-radiative recombination, that is Auger recombination. This involves only three carriers instead of having only two electron-hole recombined. One more carrier will be there. After an electron and a hole recombines with each other, the energy will be released, but rather than emitting energy in the form of heat or photon, that energy is given to the third carrier, and the electron in the conduction third carrier, which is in the conduction band. This electron then thermalizes to conduction band. Auger recombination is most important in heavily doped materials. You can see on the screen that this is an electron which is present in the valency band. Now by absorbing energy due to due to generation, the electron from the valency band get excited to conduction band, creating a hole in the valency band. So this is the hole and this is an electron which is excited to higher energy level. This process is called excitation or generation of carriers. After the generation of carriers, uh, let it be two electrons got excited to um, conduction band from the valency band, creating two holes in the valency band. Now if you support like once the electron completes its lifetime, it tries to come back to its original position or to the lower energy level by emission of energy, but that emitted energy is utilized by the second electron which is in the conduction band. It tries to excite to further conduction levels. So such energy transfer is called as Auger recombination. Here the electron got de-excited to lower energy level and energy got transferred to the other electron in the conduction level, and it got excited to the higher conduction levels. Next is trap-assisted recombination. In this recombination, this is otherwise called as Shockley-Readball recombination, where the electron which is de-exciting from the higher energy level to lower energy level get trapped in between the energy gap itself. This get trapped in the energy level which is in between the energy gap. That trapped energy level belongs to the foreign atom or due to the structural defects which are present in the material. Most of the time, this recombination exists in impure semiconductors like N-type and P-type materials, where in foreign atoms present whose energy levels are there in the energy gap between valency band to conduction band. So the electron occupying the trap is in a second step moves into the empty valency band state, thereby completing the recombination process. You can see on the screen that this is the red spot as the electron which is going to be de-excited from the conduction level. During de-excitation in the middle of the path itself, it is trapped in the another energy level, EI. This is the energy level belongs to the foreign atom. Okay. After some time, when you give when after some time, this electron will again de-excite to the lower energy level, occupying the hole in the lower energy level, completing the recombination process. Thank you.